Hi, my name is Mark, and I'm a yo-yo designer. I design yo-yos for Mk1 Yoyos, my yo-yo company, and here are some of the models that I've designed. This one is particularly interesting, the Diffraction 2. This is an update to the very first yo-yo that I designed and produced in 2018. This update was released in 2019, including on YoyoExpert, where you can find a lot of my history of yo-yo design and prototyping and all that in the forum threads there. So I thought it would be interesting to design a yo-yo, an aluminum ball bearing yo-yo, and document the entire process. Because I find it super interesting to read about other people's design experiences, and that's how I got into this as a hobby, and I thought it would be really fun to show all of you as well. So my kind of whole idea for this design is something I've been working on behind the scenes for a while now, but figured I'd kind of like show off the whole concept from scratch, which is essentially to combine this sort of shape of the Mk1 contact and give it a hub that matches the diffraction, which is pretty good for finger spins. And but also make it a bimetal to allow it to have a smaller, more compact size with a similar amount of spin and performance. Given all that, I want it to have a pretty lightweight. So you can see the contact comes in at about 62.5, and a lot of my yo-yo designs are pretty light. 64.7. The string's like maybe half a gram, so a little bit above 64. And then this is the Exia. This one is pretty heavy with the string. Let me move that. There we go. 63.78. Nice. I'm bumping into my camera stand here. So I want to take this kind of shape with a schmooze groove there, and let me just sketch this up. So let's make it like 44 millimeters wide. So a little bit narrower than the contact. And I'll make this this center line. We're gonna make this in a higher alloy. Let me put the center point here, 22. But a higher quality aluminum alloy will allow us to make a shorter axle and thus a less weight in the center of the hub. So let's go for 8 millimeters. This will be centered around right there. Looks really small, doesn't it? So the axle is going to be just about that long. It's tiny, isn't it? All right. And for the radius of the yo-yo, I said I was going to go for about 52, 53, so that would be about 26.5 for the radius. So that'll take us up to, I'm bumping into my actual yo-yos here. About right here. So this is going to be the corner, 53 by 44 millimeters. All right, now with that out of the way, I want this to have a, sorry, let me draw I should have gotten some actual tools to draft this. There we go. So these are our center lines. That's the string plane. This is the axis of rotation. And I want the yo-yo to have a, I should probably figure out where the end of the response pads is. So response pads are 9.5 millimeters in radius, or 19 millimeters radius. That's why they're called 19 millimeter pads. So let me get this calipers to 9.5, and I can put a tick mark on this vertical line showing where that is. And that'll be right there. So, and then if we have a gap width of like 4.5, so I'll put this at half that, 2.25. This really gives you a sense of how fine all the details are in a yo-yo. All right, so that means this is where the wall will begin. And the diffraction style hub is going to go in like right here. The inner one is about 12. Then the next step is about 22. So 6, and then 11 or so in radius. So yeah, close enough. That'll be a good enough estimate, I guess. So this wall, all right, there's various guts in here. I'm not gonna attempt to draw those to scale, and the axle is gonna like screw in right there. All right, so this will go, and then we're gonna have like a big round part here. And one of the things that I want to do on this yo-yo was a steel ring. So I'm gonna draw that in pink. And I want this to be pressed in from the profile side. So it needs basically a spot for that to go in right there. This line down here, this horizontal line, this is where the actual interference fit is. This vertical part here is just like the backstop, so it doesn't press in farther than it needs to. And then between these two sections, there's going to be a big schmoove. Something like that. The proportions of this are going to be a little bit different once I bring them into CAD, and we'll see how these different features all play off of each other. Let me get a more accurate measurement of this cup. So it's actually hard to do because these calipers are not super good for this. All right, so 12 for the inner one. And about 22 for the outer one. I'm going to write that down here. 22, 12. Yo-yos are really tiny as objects. So here we go. I guess we can go bring this into CAD.